going to talk about ratios, similarity, proportions, and I'm on page 245 in your book. But first of all, I want to just preface with some little background on similarity and proportions, and you're going to actually do some practice with proportions and similarity today. So in geometry, when we say that two geometric figures are similar, that just means that they have the same shape, but they do not have the same size. Now, previously, everything that we have been doing is finding congruence and determining whether or not two shapes are congruent, which means same shape and size. However, today we're talking about similarity, and that is they are the same shape, but they are not the same size, but their size is proportional, and I'll explain what that means. Okay, so if you look at the board, I have two triangles here. Now, in order for two shapes to be similar, all of their angles have to be the same. So I have drawn my little angle marks to prove to you guys that all of them are the same. But you can tell by looking at these figures that they are not the same size. They are close to the same shape, but they are not the same size. So when you think about proving something to be similar, you have to consider whether or not their sides are proportional, and I'll explain what that means. So you look at the corresponding sides of the two figures. So I have triangles A, B, and C, and in this one it's J, K, and L. And so if I'm looking at these two triangles, I can see that AC corresponds with JL, and that AB corresponds with JK, and that BC corresponds with KL. And so those are my corresponding sides. Now here's the thing about similar shapes. The corresponding sides have to be proportional. So what you do in order to prove that these two shapes are similar is that you set them up like proportions, and you have to be sure that all of them are the same. Now watch this. I put my proportional side AC over JL, and I've got 6 over 3. And when I reduce that down, that will be 2. Now, when I put my side AB over its corresponding side in proportional to JK, I've got 8 over 4, and when you reduce that down, that will be 2 as well. Now, how you prove the shape to be similar is that all of them have to be proportional, so they have to have the same proportion. It doesn't always have to be a whole number. It could be 1 over 2, it could be 1 over 4, which is a fraction, but they all have to be the same. Now, you need to make sure you are reducing them down all the way, because sometimes you may think they're not proportional because your fractions are different, but maybe you just haven't reduced it down all the way. So let's look at our last pair of corresponding sides. That's going to be side BC, which is 8, and KL, which is 4. And when I reduce that down, that is 2. So this is how I prove that triangle ABC is similar, and I would just say triangle ABC is similar to triangle JKL. And the way that you prove that is that all the angles are the same, but the sides are proportional. Now, if you get two figures and their angles are not the same, meaning you have, say for instance in a triangle, you have a 30, 60, 90, and then you have a 45, 45, 90. Those angles are not the same, so those two shapes would not be similar automatically. You don't even have to put the sides over top of each other to test to see if they're proportional. If the angles are not the same in both triangles, it is not proportional, as simple as that. Now, I do kind of want to go over some examples of proportions. So you can solve for a proportion very easy if you have a proportion in just, if you have 3 of the 4, you can solve, we know that. So of course you set up a proportion like this, you're going to cross multiply, that is going to give you a 64 equals 8x. Go ahead and divide that 8 to get x, and 8 equals x. So your proportion would be 4/8 is equal to 8/16. That is how you find proportions. When you do your proportion assignment, this is what you will be doing. Set them equal to each other, cross multiply, and solve for the missing one. Sometimes you'll have some word problems like this, and we'll talk about that a little later. But before we jump into our theorems, I wanted to kind of give you a refresher and talk to you about proportions and also similarity and what that means concerning geometric shapes, and that is they are the same shape, but they are not the same size, but their size is proportional.